Okay, so we'll start with the hackathon pitches. Before we start, just a couple of kind of technical notes on how this will proceed and announcements. So first of all, I wanted to introduce Ian, who's sitting over here. Ian is a rising second-year graduate student in psychology here at UW, but also has several years of experience as a software engineer before he came to UW, and researcher in machine learning, and so has a lot of technical knowledge that may come in handy as you're working on your hack projects, and has volunteered to help here. So in addition to Kelly and myself and any instructors that you see here that you want to sort of ask questions and get help from, you can also ask Ian for help with all the technical stuff. Okay. And then what we'll do now is I'll ask people to come either unmute yourself on Zoom or come over here and grab the microphone. If you're here in the room and pitching a project, the only thing I request is to come back here so that people on Zoom see you through this owl that's right there. So that's just so they can see your face instead of your back. And then we'll hear maybe do like a minute or two to describe what you hope to do, and then go to that Google Doc that I sent and kind of put your name under the thing that you're hoping to join or check out, and then you'll be able to sort of find each other. If you're pitching a project, the thing to do either before you pitch or after you pitch or at some point early on today is to create a Slack channel within some appropriate name, and then to invite the people who sign up on the Google Doc to join that channel, or even I guess we can do a thread in the general, so where I posted that Google Doc in the thread on after you pitch, you can post the link to the Slack channel. It's like hash in the name of the hash symbol and the name of the channel, and that will then let people kind of see where to go to have the conversation. And then after we do that, you kind of find the people here in the room or on Slack and start organizing to set up a GitHub repo. You can set up a GitHub repo. You're all now members of the Neuro Academy 2024 organization. So you can set up a GitHub repo under that organization. That will make it easier for us to find things, and then we can set up permissions as needed for doing various things with these repos. You should have pretty open permissions to do a lot of things, but let me know if you get stuck with anything GitHub related. We are planning to do some Git and GitHub clinics. So throughout this week, what will happen is every morning we will have here in Alder Auditorium and in this same Zoom room as we are using right now, we'll have what we call a stand-up meeting. What that means is we'll do something brief where every team can update on their progress, tell us where they're stuck. This is an opportunity to say, oh, if somebody knows something about topic X, this data set or this software, can we chat with you? And then we can kind of find each other after so this will just go around between the teams and hear where everyone is and kind of like a short update. So we'll do that every morning at 9 a.m. starting tomorrow morning. So 9 a.m. every morning until Friday. And then after that, tomorrow and the day after, so Tuesday and Wednesday, we're planning to do Git and GitHub clinic. So the idea is everyone who's stuck on various Git and GitHub stuff will go into 107, which is the room over there, and a Zoom link that we will send, and then we can resolve various Git and GitHub related things. If you're not stuck with those things, then you don't have to go to that. But if you get stuck with that's an opportunity for us. We know that Git and GitHub are actually probably the most technically complicated things that we're dealing with this week. So we'll have a couple of clinics on that.
So just a quick reminder, not everybody who is going to be on all of the teams is able to be here right now because some of them are in very different time zones. So please do check the sheet, and if people sign up who are in different time zones or anything online, please try to include them. Make sure to notice that. And then one thing that we always get asked sometime this week is what we expect for the final presentations. So we'll talk a little more about the final presentations later in the week. But what I'll say up front is just we encourage you to dream big and think big in terms of these projects, but you also have probably 4.5 days really to do these projects. So, you know, you're not going to get a failing grade if you like grade, as if we're going to grade you. You're not going to get a failing grade if you don't complete everything you plan to complete today. So think big, but you know, don't stress it too much. Okay.
Okay, great. And with that, that was, I guess, my pitch for my fantastic project number one. And so now we'll go to project number two, create catalog of fMRI effect sizes. Thomas, do you want to, I think you're on Zoom. Do you want to mute yourself and pitch that?
Yes, thank you. Hello, everyone. I should disclose that I'm on UK time zone, but I think I can work with the US time zone. I was really interested in Stephanie Noble's presentation on effect sizes, and Jesus, my face is big on the screen. And would like to work with effect sizes. Would be interested in text mining. Saw there was another text mining project, so it would be cool to extract effect sizes from papers, maybe using language models, or maybe writing a tool that could take in an open neuro repository and again extract effect sizes from the repository, and kind of like be able to prepare the data for something like brain effects. And I think I also got a suggestion from Dr. Pauline regarding linking to NePoppy extractors, which could be interesting. I'm reading about it as I'm reading this, but it looks like a really cool library. Would be really cool to work with that too. Really anything related to like, text mining effect sizes, I would be interested in working with. I know more about task and resting state fMRI, so yeah, that's all I could probably bring to that project.
Great, thanks a lot. Next, an interactive platform that provides coding tutorials and neuroimaging overviews. Well, maybe I'll just pass this on instead of reading all that to Cindy. Pull up this.
Yes, please. That website.
So let's see, hang on yours, yeah.
Sorry. Yeah. Okay. Perfect. So mine is an interactive platform for just being able to scroll down. Thank you. So I built this in an hour, so please just know this is a shell and not the real thing. But the idea is to basically have a place to hold resources. So this has been a really cool opportunity for me, and I'm very fortunate to have the resources to be able to come. I know a lot of people don't have the time or the resources, and I know a lot of people who want to know how to get started, whether that's with coding or imaging or a little bit of both. So the idea is to basically have a place to hold a little bit of everything. What is MRI? How do I get the data? How do I work with the data? What is CT or PET or optical imaging? The idea is to have a place where you can hold imaging resources. You can scooch down to the, right there, stop. Perfect. And then the idea is to, how do I get started with data? Whether that's data pre-processing, how do I get started with Python, open science, and data sharing? These are topics that I came up with. I think I'm really open to other topics too. But let's say I want to learn how to pre-process MRI. The idea is that you should be able to click on that, be able to go into a menu, look at MRI. What are the programs that are currently available? How do I work with them? How do I incorporate them into my workflow? The idea is that this should be for both beginners and advanced researchers. So if you're beginning out with Python, you've never used it before, there should be an example of how to do that. And if you are advanced, how do you work with these really cool libraries that already exist? You may be thinking, Cindy, how do I be a part of this project? That's a great question. What I'm hoping is that people will bring their own expertise to this project. So when you are clinical and you want to show how do you work with clinical data and then what kind of Python libraries exist to be able to work with clinical data, you would be able to include that in these beautiful boxes. Okay, I think that's everything.
Great, thanks a lot. And if you want to join that one, you can put your name under free. Oh, yeah. I'm gonna do that. All right, next, Alex Rockhill, who was remote. Oh, okay. Okay, great.
I probably.
He might be on his way or maybe still on Zoom somewhere. Okay, well, you can represent him.
I'll try my best. So Alex is into motor stuff. He wants to study, he's a postdoc in University of Oregon. So what he wants to do is like, he would like to use monkey data from grasp experiments, using ultrasound, I think it was the kind of data. And he wants to use the database that Dr. Mueller mentioned us during his talk on finger movement. So what he wants to do, he wants to apply deep learning algorithms to see how CNN will perform in both and how like could be improved or stuff like that, fun stuff that he likes. So please join him if you are into like motor stuff or just like deep learning models and stuff like that. So that's it.
Yeah, thanks. I'll just add that I chatted with Alex a little bit about this, and so there's some data on the hub. He even sent me some example code that he wrote. So if you're interested in this, there's stuff to get you started, and then hopefully Alex will show up and continue growing from there. Okay, next is number 5. There's several of you there. Who wants to come up and talk about this?
Hi everyone, I'm Loretta, and I'm proposing TLDR, or too long didn't read scientific journals and data. So my little pitch is reading an article takes time, money, and effort. Before you know it, you're taking an afternoon nap while reading through a 20-page review on the inner workings of magnetic resonance spectroscopy. So wouldn't it be nice if we had a too long didn't read version of the articles and data that you need to sift through? So the idea is kind of expanding on some other types. I've already gotten some people contributing to links of things that already exist that's AI generated, but we want to expand on it and kind of create like a graphic. So we're trying to output like every single article we would output objectives, hypothesis, and end treatments, kind of all the necessary data you need in order to do a lit review. And that way it would just be a 1-page document instead of a whole entire journal article you have to read. And it will have all the necessary information you want. We're also thinking of inputting an actual physical graphic. We need a lot of help on this, but we're trying to implement machine learning too to kind of expand. We'll start with neuroimaging kind of journals and then expand into other fields. And then there's also some talk of having links, so to kind of fact check what you're getting outputted within this algorithm. We'll fact check and it'll link the text that it's giving you back to the article to actually highlight and show it. I don't know how to do that, and the rest of our team doesn't know how to do that. So if you'd like to join us, more than willing to add people. But yeah, come to TLDR. Thanks, guys.
Right. All right. The next one has some slides. Number 6.
Where do I get the slides?
They're on the Google Docs. If you go to Slack to general, it's a link.
The size is just text that I was gonna.
In the
talk
general.
about.
Yeah. General. That one. And then from there on number 6, there's a. Right.
So, hi everyone, I'm Michelle. The project that I'm pitching is about exploring distributed learning for multi-centric analysis. So distributed learning or federated learning is a type of, so for example, when you have multiple data sets that have, for example, clinical data that can be shared easily either at the participant level or even at the summary statistics level, then how do you incorporate all of these data together in a single analysis to have more statistical power to be able to draw conclusions for things that potentially have very small effect sizes or negative results. So some examples of this would be what I think is known as a traveling model kind of thing, where the different sites, pull a model, train it on their local data, and then push the updated model somewhere. And then this is then like in the sequence, and then there's like a lot of variations, and I don't know too much about it, but I'm very interested. So I think this would be a good learning opportunity. And then there's other things like training separate models and then combining them together, but all like with the common line of the data always being local and never being uploaded anywhere. So what I'm thinking for this, for the roadmap, would be some sort of literature review, because everyone has said that to learn, and including me, about this. And then brainstorming on how it would be done, and especially if we have like some generic software framework that could be easily extended to different types of analyses for that. And then implement something potentially very basic and not very interesting on the like scientific level, but that could be extended, and then eventually we can have more complex models that could be like integrated into that very easily. Yeah, so the learning outcomes that I'm thinking of for this would be distributed learning and like statistics, for example, like how do you learn information using from in this type of federated learning paradigm. And also a lot of technical things. I think this is actually probably going to be more of a technical implementation project, but container things, and then pipeline, and probably Python scripting, and of course Git and GitHub. And yeah, so finally, if you could advance anything, deliverables, first thing would be just a general framework of how to go about this type of thing, and basic prototype on what I'm thinking currently is just if we are able to learn the mean and the variance for example, different groups in data sets, then you can implement something like a distributed t-test kind of thing. So very, very basic, possibly with covariates, something that Judy mentioned. And also if time permits, then we could try to do kind of more of machine learning kind of analyses like that. But yeah. Thank you.
All right, next, number 7, Sophia, do you wanna?
Hi, everyone, I'm Sophia. I'm really interested in building some sort of interactive web app, specifically learning how to use the tools Voila and Voichi, I think is how it's pronounced. It was posted in the, I think, web app Slack channel earlier in the week. So I'm really interested in kind of learning how to use those, and we can make like an interactive web app that maybe explores one of the publicly available data sets that we learned about, or something on OpenNeuro. And yeah, basically an interactive platform to explore a data set, and also in the meantime, kind of also use it to teach some sort of fundamental neuroscience concepts, depending on what the data set is, through this more of like an interactive platform. Yeah.
Very cool. All right, number 8, Teresa.
Hey everyone, I'm Teresa. I have 2 pitches, so I really don't know what I'm doing yet. But number 1 is more of a not necessarily one that is intensive in terms of coding and data, but more specifically addresses it's just like born out of irritation. So essentially, like it's this problem of, you know, you really are working on a project, you're interested in something that somebody else has already done in terms of like a variable that they've created, so a data derivative. But that derivative is, you may be created by a lab member that's left, or maybe buried in line 1000 of some code that doesn't really work unless you run the whole thing from the beginning or something like that. And so I guess there's a lot of like standardization for things that are really upstream, like bids, but then in terms of thinking about data derivatives, I kind of want to build maybe a set of best practices, maybe code templates, and maybe thinking about like when in the workflow there might be accountability for this kind of thing in relation to data derivatives in general. So that's idea number 1. I'll just launch into idea number 2. So the other thing that I'm kind of interested in doing is just really getting into the data. And so one idea that I had that I thought would be feasible for this week is essentially, I've been curious about naturalistic movie watching data, have never used it. I noticed there's a lot of it in the Healthy Brains Network data set. And so I thought it'd be cool to get into that data set, extract one variable. I have one of interest that I put up that is essentially fluctuation amplitude that some people are proposing is related to changes in developmental plasticity. But I'm not tied to that. I think like entropy, like there are other kinds of metrics that could be interesting. But the idea of getting into that data, pulling out one metric and looking at age-related change, because I think age is one of the variables we can pull out without needing a data use agreement or anything too fancy. So those are my pitches. Thanks.
Great. Number 10. Angelina, I see your name. Do you want to unmute? Or maybe somebody else? Haruka? Oh, Dixon, okay.
Yes, I was just gonna say that we have someone in person, so that should be better.
Okay, yeah, we'll give Dixon the microphone. There you go. Here, maybe stand.
Hi, everyone. So very early stages, but we identified a data set that we want to look at with the Human Connectome Project. It's specifically with patients who have had disordered diseases of emotion. And so we want to look at kind of like, it's a very open-ended project. We're still kind of discussing things, but essentially we'll want to look at different brain regions that are notably activated in patients and young adults who have anxiety and depression. So it's a very exploratory study. So we have a lot of ideas to come up with. So yeah, that's a summary of the project.
Great, thanks a lot.
Yep.
All right, 11, Leah.
Hi, everybody.
Oh, stay back here.
Stay back here. I can see you through that.
Is it
Oh,
actually
that
on?
turn
I
off?
think it turned up.
If you hold down the button on the bottom for seconds.
Oh, there you go.
Hi, everybody. My name is Leah, and in my lab in Germany, a toolbox was created to do a class connectivity-based parcellation based on functional and structural connectivity. But this has been done on volume space, and I want to adapt it to work on surface space. So the toolbox is already created, it's open source, and it has a GitHub repo. But yeah, and we would be working with the HCP young adults data set. So if you're interested in Git and surface space analysis and functional connectivity, you could join this project. Yeah.
Great. All right, number 12.
Thank you. Hi, I'm Ella. So for my pitch, it's a visual attention project. So the saliency map is an image that highlights the region of which people's eyes focus, and it's a great way to study visual attention and highlight areas of interest to the human eye. And visual saliency maps can be estimated from eye tracking data, but recent studies have been able to do this with the EEG data as well. So I thought it would be interesting to include eye tracking signals in the loop to design a feedback loop to improve saliency map estimation and maybe even be able to compare models using EEG versus eye tracking or both down the line. And I found an open source data set that has both the EEG and eye tracking data collected.
Perfect. All right, number 13, Dylan. Let me stand back here. So I see you.
Hey, I am interested in sort of merging data science with the clinical space. So one thing that we encounter in the clinic is obviously like patients come in and they have like a set of characteristics, and clinicians are sort of tasked with providing a diagnosis, a psychiatric diagnosis. But the way we do that is mostly through like qualitative means. So we'll like look through the literature and find, like our patient is belonging to these groups and has these symptoms. So what diagnosis are they most likely to have? But there's no way to approach that quantitatively. So my idea is to create a platform where people can, contributors can, well, basically download a toolbox, and the toolbox will have prediction algorithms built in, as simple as like linear regressions. And then you can select the features that you want to include and the outcome that you want to include, a diagnosis or some other clinical outcome. And then you'll, the toolbox will run the algorithm. It'll spit out something that's just a prediction algorithm. So there's no need to like share data. And then the algorithm will be online somewhere on GitHub. And then the users, the clinicians with the patients will be able to search for their the demographic of their patient and find the best algorithm that that serves their purposes. They'll be able to input their characteristics into just like an equation, x1, x2, x3, etc. And then they'll get a number for the probability of this patient having a disorder or having some other sort of clinical outcome. And then the open science idea of it would be other contributors could use their own data as like validation sets, so they could train these already published algorithms on their own data, and then we could improve the algorithms that way potentially. Yeah, so that's my idea.
Great. The next one is number 14. Ashley. You have two ideas.
No, I only have one.
Oh.
Oh, there's two Ashleys.
Oh, another Ashley.
Okay.
Another Ashley.
Hey everyone, my name is Ashley and I don't have like a new idea. I just want to contribute to an existing idea. So the neuroprism people presented on brain effects, and I just wanted to add to this. So I had some ideas such as adding helper text and buttons to the website to make it more tutorialized, figuring out how to easily download effect maps and graph them. This might actually move to be like a power calculator. So I'm down to do that. If it's possible to do it in a week, I don't think it will be. And other, helpful tools to add to this already existing resource, because I want to make it better and just try to help them out. So if you're down for that, then you can help me. I think it'll involve a lot of GitHub and Shiny apps. So yeah.
That's great. And the last one we have here is number 15.
Sorry, that's me from online.
Okay. Hey.
Yeah, sorry about that. I also was like, I'm not sure for these pitches. I feel like my idea isn't very fleshed out. I haven't really had a chance to kind of brainstorm or discuss with others about it, but just something I wanted to kind of throw out there to see if there's any other interest. It's to generate like a report for like a bids directory. So I came up with this idea because of a very specific problem that I've encountered when dealing with bids formatting subjects across multiple sites. In an ideal world, every single bids directory would have the exact sequences and the acquisition would be perfect. But in reality, there tends to be a lot of variations between the different sessions. So essentially what I'd want to do is create a tool that would generate a bids report and also perform some sort of like site validation. So the bids validator checks to make sure that all of the like sequences are like bids compliant, but this would make sure that the acquisition was site compliant. So I would basically like kind of create a config file that say for site A, I expect there to be a diffusion sequence with this image shape. I expect there to be a functional like scan with this shape or this many volumes. So it would do that kind of validation. And then you could also like make a nice report that just like has all the summary statistics. You could also like plot the BVEX on the sphere or like visualize the ASL like tag control pairs within the volume. So it just kind of give you like a nice overview of your bits directory to make sure that everything looks good in terms of how the data was acquired.
Cool, very cool. All right, so you've heard all the pitches, and now is the time to sort of figure out where you fit in with all these things. I hope that you've started creating Slack channels for the various projects with informative names, posted those into that thread. And so that's a good place to find each other.
Also, if anyone didn't put their project in the list or would like to pitch a project that they just came up with now's your chance.
You can always do it later. Oh, here.
Okay, yeah.
One more. Here, come in from here.
Okay.
All right.
Ours isn't completely fleshed out either, but there's a group of us who use functional imaging and we're really interested in looking at a different methodology. So diffusion imaging, so it's more of an exploratory project. We're really interested in implementing the tools that we've learned here, such as creating a Docker image, creating our own libraries, working on GitHub collaboration. So just best practices of coding and scripting, and also using HCP data, so downloading open data and implementing that as well. So it's more of an exploratory analysis of just a basic introduction to diffusion imaging, and also learning how to analyze that with the tools that we've learned here, such as libraries and packages. So super open to more ideas or further fleshed out thoughts.
Perfect. All right, any other late breaking ideas? I should say at any point you can decide you want to do, you have some idea, you want to explore that, splinter off from something into something else and so on. This is meant to be primarily driven by you this week. Okay, if not, then let's kind of start figuring out what we're doing, and we'll be around to help you sort out things like finding each other, creating GitHub repos and so on.